Hey everybody, in this video we are going to learn about the ideal gas law and explain every letter and every unit, and this is being done by the soft-spoken scientist, alright, your favorite. So let's get started. First of all, what is the ideal gas law, right? So this is the ideal gas law in the box, PV equals nRT. This equation is called the ideal gas law. It describes how pressure, volume, temperature, and amount of gas are related. So P stands for pressure. Pressure tells us how hard gas particles are hitting the walls of a container. ATM is the most common unit for pressure in general chemistry. In this video, we will use atmospheres or ATM. All right, let's move on. And I'm sure on your tests, it'll be ATM. Okay, volume. V is for volume. Volume tells us how much space the gas occupies. Liters is required for this equation. You have to use liters. Do not use milliliters, okay? If you get milliliters in a question, you gotta convert it. You can use King Henry died by drinking chocolate milk, right? So this is your milliliters. B is your base, which is including grams and liters. So then you would just boop, boop, boop. You would move to the left 3 times. All right, now let's talk about N equals amount of gas, right? It is measured in moles. If a problem gives grams, we must convert grams to moles first. In this video, all values are already in moles. I'll do another video about that. All right, temperature. T is temperature, and this is extremely important. Temperature must always be in Kelvin, all right? And to get Kelvin, the formula is right here, you guys. It's degrees Celsius, it's just a circle, degrees Celsius plus 273. If you use Celsius instead of Kelvin, the problem is wrong. Now you have a constant. R is a constant. This specific value of R is used only when pressure is in ATM, volume is in liters, temperature is in Kelvin, amount is in moles. Let's do a practice problem, and you guys will pick up what I'm putting down. All right. Boop. Okay. Took me a second there. Okay. A gas has a pressure of 1.20 ATM, volume of 10 liters, amount equals 0.500 moles. Find the temperature in Kelvin. Before plugging in numbers, we always rearrange the equation. We got PIV NRT. Okay, I need to have temperature alone because I need to find out what temperature is equal to. So I'm gonna put a line here and like another line. I'm going to divide by N times R on both, because what I do on one side, I gotta do to the other. By dividing by NR, I canceled it out. N divided by N is 1, R divided by R is 1, so it's just nothing, just T. So I got temperature equals pressure times volume divided by N times R. This is the formula we are gonna be using, y'all. Pressure is in ATM, volume is in liters, moles are given, and R matches these units, so we are ready to plug in. So I'm gonna say temperature equals 12.0 ATM times 10.0 liters, because that would be my volume. PIV, and then NR would be 0.500 moles times 0.08206. All right. Now you may be asking, well, what's the unit for 0.08206? Remember, it's liters times ATM times mole, all over moles times Kelvin. So this is what I have. Let's cross off some units we don't need, huh? So we got ATM up here. We got ATM down there. Perfect. I got liters up here, and I got liters up here. Perfect. Notice how ATM and liters were all in the numerator above here, and then they were in the numerator above here. But it's still opposites because it's under the division bar, if that makes sense. So that would cancel out. I'll use a different color, and maybe you guys could recall this. Then I have mole up here in the numerator under the bar, all over moles over here. It's up here, and then mole was down here in pink. So guess what? I'm left with the K. So I know I'm gonna set all of this up correctly. When I do this on my calculator, I multiply the numerator, and I multiply the denominator across. I do 12 times 10, and then I get that number, I write it here, and then I get another number from doing 0.500 times 0.08206. I get another number. That's the proper way to type it in the calculator. Like right on the side, oh, this numerator is 7, and then 5, you know. Okay, so by doing that on my calculator, I got 293 Kelvin. Because temperature is already in Kelvin, we are done. Let's try practice problem 2, you guys. A gas sample contains 1.50 moles, volume is 12.0 liters, and the temperature is 300 Kelvin. Find the pressure in ATM. So, I want pressure, and all I know is this formula, PIV nRT. I'm going to divide both sides by volume, because I want to know what P is equal to. I want P all by itself to know to find the pressure. So I have nRT all over V. So pressure is equal to the N, which is 1.50 moles, times the R constant, 0.08206, liters times ATM, all over mole times K, right? Okay, so now what's the temperature? 300 K. All right. There we go. All over the volume, which is 12.0 liters. Now I'm not going to start plugging it in on my calculator. Let's see if I did it right. I have moles up here and then moles down here. I did that right. I got Kelvin up here. I got Kelvin down there. I know I did that right. I got black. Okay. I got liters up here. I got liters down there. I know I did it right. Pressure is with ATM. That is the unit. So I did set it up correctly. In the numerator, you would multiply them. In the denominator, you would multiply it to anything if there was one. So, by multiplying the entire numerator, I would get a number divided by that denominator. It would be P equals 36.9 divided by 12.0. And then you guys should get pressure is equal to 3.08 atmospheres. All right, this is your answer. You had the lowest amount of sig figs you guys had was 3. 1, 2, 3, or 1, 2, 3, or 1, 2, 3. Oh no, that's not a good one. Remember, see, they almost tricked me there. There has to be a decimal for the zeros to count. So I think if you guys want more practice problems on PIV nRT, ideal gas law, you know, please feel free to let me know, because I was going to do more practice videos, but I think there were other laws that I should probably go over. All right, let's go over the next problem, practice problem 3. So here we are told a gas at pressure of 0.950, a volume of 20 liters, and a temperature of 298 Kelvin. And they want to know how many moles of gas are present. So we have to write out our formula, which is PIV nRT. All right. How many moles? They're asking for the N. So I need to divide both sides by RT to get rid of it. I want N alone. So I have N equals PIV divided by RT. Because what I did on one side, I must do to the other. Okay. So let's plug it in, right? We got N equals the pressure of 0.950 ATM times a volume of 20.0 liters, all over 0.08206 of liters times ATM, all over mole times K. It's a lot of work you guys do. Times temperature of 298 Kelvin, right? So look at this. Liters cancels out. ATM cancels out. Kelvin. I guess you could think of it as like, oh, technically they're both in the denominator, because this one is and this one's in another one, under one. So I said to myself, okay, N is for how many moles, and we are at the correct unit. So I know I plugged everything up correctly. I'm happy about that. And I know I have how many sig figs? 1, 2, 3. 1, 2, 3. 1, 2, 3. Yep, that's the lowest one, 3. So I need 3 significant figures. So I'm going to do the division on my calculator, and I get n equals 0. That doesn't count as a sig fig, it's before the decimal point, 776 moles. That was the answer. Let's try this one. A gas occupies 5 liters at 1 atm and 27 degrees Celsius. How many moles of gas are present now? Okay, so first things first, I don't like degrees Celsius. I need to use the formula to change that into Kelvin. 27, so degrees Celsius, plus 273 equals 300 Kelvin, right? Because look at this. What's 7 plus 3? 10. 0 goes down here, 1 goes up here to the neighbor. What's 7 plus 1? 8. What's 8 plus 2? 10. 0 here, 1 up here again. 2 plus 1 is 3. 300. Okay. We never use Celsius in gas law equations. Can't express that enough. Okay. So we got Pivner again. We got to rearrange the formula because I need the letter by itself. I'm going to divide both sides by RT again because I don't want this next to my N. I need it gone. So I have N equals Piv divided by RT. All right? So let's substitute. We got a pressure of 1 atm times the volume of 5 liters. And then I have to divide by 0.08206 liters times atm, all over moles times K. Boop, boop, right? And then temperature is 300 Kelvin. So check this out. ATM cancels out with ATM. Liters cancels out with liters. Kelvin cancels out with the Kelvin denominator down there. So then and is with moles, and I don't want to be confused on that. So it makes sense. So what I'm going to do now is plug that all into my calculator. I got 5.00 divided by 24.6, and that would give me 0.203 moles, 3 significant figures. That was my final answer. Most students lose points because they forget to convert Celsius to Kelvin. Don't do that. Or they use the wrong value of R. Don't do that. Or they mix units. Don't do that. Or they plug numbers in before rearranging. Don't do that. Okay. Let's try this problem. Where is it? Maybe I skipped one. Okay, there we go. So, for this one, we say we have, where is it? There he is. A sealed container holds a gas at 2.50 atm and 18 liters. If the temperature is 298 Kelvin, how many moles of gas are in the container? So let's plug in let's identify what we know. We know pressure is 2.50 atm. Volume is 18.0 liters. The temperature is 298 Kelvin. This is all stuff they just told me. Bam, bam, bam. That's the pressure unit. That's the temperature unit. That's the volume unit. How many moles of gas are in the container? Oh, I don't know that, so I gotta find N. And I already know my R because it's a given for everything. Even if they don't explicitly write it, you guys know R is 0.08206 with L times ATM all over mole times K, don't you? Okay, I hope you do. So, we got Pivner. Again, I want N by itself to solve how many moles of gas. That's how many moles of gas, that's a fancy way of saying find N. Specifically lowercase n. Okay. Divide both sides by RT. Cancel out, cancel out. N equals PV all over RT. So, we have P of 2.50 atm times the volume of 18.0 liters. So far, everything's looking like 3 sig figs, times 0.08206 times L times ATM, all over mole times K. And then temperature was what? 298 Kelvin? Okay. So let's identify units. ATM cancels out with ATM. Liters cancels out with liter. Mole down here cancels out with, oh, it doesn't cancel out. And then you got Kelvin up here that cancels out with the one down here. So you got mole. And you're with N, you want no moles, you guys. So Doing 2.50 times 18, you'll get 45.0. 0.08206 times 298, you're going to get 24.5. All over with 45.0 in the numerator. So you have 1.84 moles. This is your final answer on that, all right? It can be a bit tricky, but you know, practice this, you guys, and I'm sure there won't be any issues with these types of problems. Let's try this one. A gas sample contains 0.750 moles of gas and occupies 15.0 liters at a temperature of 35 degrees Celsius. What's the pressure of the gas in atmospheres? Okay, first things first, change that temperature. This is not cool. We want it in Kelvin, right? So take 35 plus 273. 273 plus 35. There is a nice way of doing it. And by doing the math, you can see I got 308, right? So I got 308 Kelvin. Anytime we see Celsius, we convert first. So let's identify what we know. We don't know P. What is the pressure? I don't know. They're asking me for it. And then volume is 15.0 liters. The N is 0.750 moles. The R is always the same old, even if they don't write it, you know what it is. Right? Look at all of those units. R is really something. Okay, and then temperature is 308 Kelvin, right? So, we got this formula Pivner. Let's rearrange. I don't want to know what PV equals. I want to know what just P equals. I'm going to divide both sides by V. Goodbye. It's gone on that side. What I do on one side, I got to do to the other. So I got P equals nRT divided by V. Okay, that's rearranged. Let's plug in the formula. So I got P equals 0.750 moles times 0.08206 times L times ATM all over moles times Kelvin. The temperature would be 308 Kelvin all over a volume of 15.0 liters, right? So, liters cancels out with liters. Moles cancels out with moles. Kelvin cancels out with Kelvin. But look at that. This ATM did not cancel out with the pressure, right? So I multiply my numerator, all of them together, and I got 18.9 divided by 15.0. 3 sig figs, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right. So the answer has to be 3 sig figs. So 1.26 ATM. So I know that was a bit of a doozy, but with practice, you will definitely make progress and make even perfect the more you practice it. So if you understand what P, V, N, R, and T actually mean, the math becomes pretty straightforward. I thank you guys for tuning in and watching me, and please hit that like button if you liked it. Please hit that subscribe button if you really liked it, and please remember, STEM is for everybody, especially you. Great job.